Section 1.9, a little geometry review, looking at distance and midpoint formulas and applying them to circles. So we will review finding the distance between 2 points, finding the midpoint of a line segment, write the standard form of a circle's equation, give the center and radius of a circle whose equation is in standard form, and then convert the general form of a circle's equation to standard form. So the distance formula, the distance between 2 points, x1, y1, and x2, y2 in the rectangular coordinate system is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. To compute the distance between 2 points, find the square of the difference between the x-coordinates plus the square of the difference between the y-coordinates. The principal square root of this sum is the distance. Principal means the positive square root, since the distance can never be a negative value. For example, given two ordered pairs, -1, 3 and 2, 3, find the distance between those 2 points and express the answer in simplest radical form and then round to 2 decimal places. So you'll have 2 answers within this. So again, just a little reminder that first ordered pair is your x values, your x1, y1 values, and then your second ordered pair is an x2, y2 values, and plug it in. If you want to call them x2 and x1 in reverse of what I have written down, it really doesn't matter which order you go in. You just need to be consistent. So our distance is going to equal, we have the square root of, I'm going to take my x2 value of 2, minus a -1, which means we would add 1, then we'll square that, plus our y2, which is 3, minus our y1 minus a negative, means we have a plus 3, and we have a squared. So we have our square root of 2 plus 1 is 3, so we have 3 squared plus 3 gives us 6 squared. So we have a 9 plus a 36, which is going to give us a square root of 45. Now they want it in simplest radical form, and they want it as a decimal. So if I take a square root of 45 and I break that down, I know that that's a square root of 9 times the square root of 5. So that means we have a 3 square root of 5. And if we just plug it into a calculator, the calculator is going to give us approximately 6.71 in terms of the square root of the 45. Midpoint formula, again, review of some geometry stuff. Midpoint, the very middle of a segment. So it says consider a line segment whose endpoints are x1, y1, and x2, y2. The coordinates of the segment's midpoints, you're finding the average of the x values and the average of the y values. So the x values added together, divide by 2. The y values added together, divide by 2. So it said to find the midpoint, take the average of the 2 x coordinates and the average of the 2 y coordinates. So, for example, if I gave you the ordered pair 1, 2 and 7, -3, find the midpoint. We're going to take our x values and add them. So 1 plus 7 would end up giving us 8. When we divide that by 2, that's going to give us 8 divided by 2, which gives us 4. I take my 2 and I add a -3, and then I divide that by 2. So it's going to give us a -1/2. So the coordinates of my mid-segment are 4, -1/2. Nice and easy, right? Definition of a circle. I'm not sure how in-depth you got with the geometry aspect of the circle and the equation of a circle. It says that a circle is the set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the circle's center to any point on the circle is called the radius. So the standard form of the equation of a circle, it says the standard form of the equation of a circle with center h, k, and radius r is we're going to have x minus h squared plus y minus k squared is going to equal r squared. Now the general, very basic concept of a circle is if you would have had an x squared plus a y squared is equal to r squared. That would be if you were at the origin. So if you had a circle that was centered at the origin, you would not have an h value or a k value because those would be 0. So all that's doing is taking that into what happens if we move the center of the circle to a different location. So x is related to how far across the x-axis we go, and the k is going to talk about up and down value, the y value. So an example, it says finding the standard form of a circle's equation. It tells us to write the standard form of the equation of the circle with center of 0, -6, and radius of 10. So we have an x minus h, so that means all we're going to do is take this 0 and plug this in for h, and take that -6 and plug it in for k. So we're going to have an x minus 0 squared plus a y minus a -6 squared is equal to r of 10 squared. Well, x minus 0 is just going to give us x. That's going to be squared. We'd have plus, and then we have a y plus 6 that's going to be squared, and that's going to end up equaling 100. So the standard form of the equation of this circle is just going to be exactly that. X squared plus, in parentheses, y plus 6 squared is equal to 100. All right, an example, looking at the standard form of a circle's equation to graph the circle. It says to find the center and the radius of the circle, whose equation is x plus 3 squared plus y minus 1 squared is equal to 4. It says to graph the equation and use the graph of the equation to identify the relation's domain and range. Now again, they say the relations. This is not a function because if you think about a circle, that is not going to pass the vertical line test. So it is not a function, it's a relation. All right, so if we were to find the center of our circle, we need to identify how our x value has shifted. So if I have a plus 3, the general form had said x minus h squared. So if this is a plus 3, it kind of goes back to our idea of our transformations. Inside of those parentheses is going to have to put inside of our brain, and it's going to go opposite of what we think. So it's read as a plus 3, which means it's really going to end up going to an x value of -3. And then we would have had added with the y minus k that would have been squared. So again, if we look inside, you don't have to really memorize what the setup of it is. If you remember transformation-wise, inside of the parentheses, put it inside your head and do opposite of what you think. That says y minus 1, which means we're going to have a positive 1. So the center of our circle is going to be at -3, 1. And then I need to identify what number times itself would have given us 4, because if you remember with our equation, we said the radius would have been some number that was squared. So if we have a 4, that means we're really taking the square root of 4, which is going to give us 2. So we're going to plot our center of our circle at -3, positive 1. And then we have a radius of 2. And the easiest way to do this is to take and count out 2 to the right, 2 up, 2 to the left, and then 2 down. And that's going to give you a general idea as to how to go about drawing out your circle. Do it the best that you can. From there, it wants to know what is the domain and what is the range. So domain, as we go from left to right, the smallest value that we have, domain, the smallest value we had was over here at a -5, and the greatest value we have is a -1. And those are going to be equal to it because it's going to be exactly 2 units away, 2 spaces away from the center of that circle was our radius. So we're going to go from -5 to -1 inclusive. So we're going to have a domain of -5 to -1 inclusive. So we have our brackets. If I look up and down, the very smallest I have is a -1, and the very largest I have is a positive 3. So I'm going to go from -1 to 3 inclusive. So -1 to 3 inclusive. Now, the last piece that they kind of talk about is the general form of the equation of a circle. So what they're going to do is they're going to go and kind of expand this whole thing out. When we had it as our standard form, we had the parentheses with things squared. When we go to a general form, that means we need to go ahead and multiply out all of those whatever in parentheses squareds were and simplify down as much as we can. Or in some cases, go backwards. So they're going to give us, so it says the general form of the equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. D, E, and f are real numbers. So if they give us an x squared plus a y squared plus a 4x minus a 4y minus a 1 equals 0, they want us to take that ugliness back into what would it look like where we have those nice parentheses that we can identify the center and the radius easily. So they want us to write it in standard form. So first thing I would recommend doing is get all the x terms together, get all the y terms together, and let's throw that extra number off to the other side of the equal sign, because eventually the plain numbers are going to end up giving us information about our radius. So if I have an x squared and a 4x, that means I have an x squared plus a 4x. I have a positive y and a minus 4y plus y, positive y squared, and that minus 4y. And while I'm at it, I'm going to move that minus 1 over to give me a positive 1. And now I need to use some of those prerequisite skills to figure out how can I make each of these pieces into something that was squared, which means I need to complete the square. We're going to complete the square. How do we complete the square? Dig back in that long-term memory. We're going to take the b value and divide it by 2 and then square it. Because remember, we have those square double squareds that we're looking for. So we need to take the b value and half that and then square it to figure out what is that extra piece I need to add in there. So if I take this b value of 4, I divide it by 2 and I square it, I'm going to have 2 squared, which is 4, which means I'm going to have an x squared plus a 4x plus a 4 to get an x plus 2 that's squared. Well, if I add in a plus 4 here, where else do I need to add in a plus 4? I also need to add in a plus 4 over on the other side of the equal sign. If I take the next section, my y values, I'm going to take my b value, which is a negative 4, divide by 2, and square that. Negative 4 divided by 2 is a negative 2. Negative 2 squared gives me a positive 4. So that means I'm going to have a y squared minus a 4y plus 4. And if I add 4 here, I'm going to add 4 there. And this is going to end up giving me a y minus 2 that's squared. If you forget how to complete the squared, go back to chapter 1. Prerequisite skills was when we completed the squared. And then all together, when I add these pieces, I have 4 plus 4 plus 1, which is going to give me 9. And now I can identify the center of the circle. I have a plus 2 with my x value, which means my center of my circle is going to end up being at a negative 2. And then I have a minus 2 for my y value, which means I'm going to have the center at a positive 2. And then the radius, if I have a radius of 9, the square root of 9 is going to give us a radius of 3. So I'm going to go over to my graph. I'm going to center circle. I need a negative 2, positive 2. That's going to be the center of my circle. And then my radius, I'm going to count out 3. So I'm going to go up 3, I'm going to go down 3, left 3, right 3, and do the best I can to draw out what a circle is going to look like. And I've just graphed my circle.